Hello, Cappuccino. Today we are talking about piecewise functions. So sometimes we have situations where a single equation cannot describe a given graph. So in those cases, we use a piecewise function. So for example, I went for a hike and somebody dropped me off 20 miles from my house. And then 9 hours later, I ended up back home. And you can see the progression of my hike here. So for the first 3 hours, I was making pretty steady progress. And then I kind of flatlined here and I didn't make any progress at all. Took a very long break. And then the last 2 hours, I hightailed it home. I went much faster getting back home. So I can't write a single equation to represent this graph, but I can write a piecewise function by looking at these 3 different distinct sections here and writing equations for each of them. So that's what I'm going to do. First is I'm going to write 3 equations for the 3 parts of my journey. So I'm going to call this point A, point B, point C, and point D just for easy of reference. And so the journey from A to B, I can write an equation of that line. That is a straight line. And I can write its equation. I can tell just by looking at it what's going on here. So I am going to write that the segment from A to B, I could write an equation for that. Y equals, let's look at my slope, my rise and my run. It's going down 10, so negative 10. And it's going over 3 hours, x plus the y-intercept. Well, I can see the y-intercept. It's right there, is 20. So I can just write that without much trouble at all. Okay, the next part of my journey from B to C, I can write an equation for that. Well, that's just a horizontal line. Y is always equal to 10. So that's pretty straightforward. And then the last part from C to D, I can see my slope is going down 10, so negative 10, and going over 2 hours, so negative 10 over 2x. I'm sorry, I'm laughing. My dog is like going crazy over here. I don't know why. And then the y-intercept, well, the y-intercept, I'm just going to like go backwards. If I just went this way, if I extended this, since I can see my slope, the pattern here, if I just continued this back up, I would end up hitting the y-axis right here. I could do some calculations to figure this out, but I'm just going to look at it. 30, 45, that would be 45, so plus 45. All right, so I was able to write equations just by looking at my graph for the 3 different sections. So these can be represented as a single function by including the domain for each of these sections. So this is how we're going to do it. Okay, so we're going to write that down. These can be represented as a piecewise function by including their domains. All right, so this is how we're going to do it. We are going to write f of x, okay, my function, and x is my hours here, so that's my x, right? F of x is equal to, and I'm going to do this in 3 pieces. I'm going to take the first line, which is negative 10 thirds x plus 20. And the second one, which is y is equal to 10, so I'm just going to write 10. And the third one, I'm going to go ahead and simplify that. Negative 10 divided by 2 is negative 5, so I'm going to get negative 5x plus 45. And then we do this. We put a giant bracket or brace, I guess that's called, giant brace like that. And then we're going to put the domain over here. So when am I using this line? I'm using it from when x is 0 until x is 3. So it's going to be x is greater than or equal to 0, because I do have a closed circle right there. And the thing we have to be careful about is the 3, this point right here, does it belong to the previous line or does it belong to the next one? And in this case, we're going to say when we do these piecewise functions, we give it to the next one. So, so for the first one, we're going up to 3, but not including 3. We're going to let it belong to the next piece. So the next piece is going to start at 3. And so when x is 3 is where it starts, and where does it end? It ends right here at x equals 7. Okay, but notice this is continuous. It's going on to the next piece. So this belongs, the 7 is going to belong to the next piece. So we have 7 is less than or equal to x, which is less than 9. And in this case, since we do have a closed circle there and there's nothing else happening, that we're going to go ahead and close it off and say less than or equal to 9, because that's the end of the function. We've sealed it off. All right, so if I was given a function like this, say I didn't have the graph, I was just given a function like this, a piecewise function, and I was asked, find f of 8. If I wanted to find f of 8, well, does that mean I have to plug it into all of them? No. What I have to do is I have to look at the domains and figure out which part of the function does the 8 fall into the domain of. Okay, so where is this going to fit? So I find the domain that it fits into. So 8 is going to fit into this domain, and I'm going to use that function in order to find f of 8. Okay, so the 8, the value, falls into the domain of the last piece. So we're going to use just this piece. So f of 8 is going to be equal to -5 times 8 plus 45. And -5 times 8 is 40. -40 plus 45 would be equal to 5. Okay, so we can evaluate a function at a value of x by making sure we select the right piece. So you have to inspect the domains to figure out which one you're going to use. All right, so that is piecewise functions, and you're going to have an assignment in MathSpace to work on your piecewise functions. And the one thing that I want you to pay attention to when you're doing the piecewise functions in MathSpace is they're going to talk about continuity, and they're going to talk about, is a function defined for a certain value. So notice my points here on the graph, they're closed circles. So my function is defined on every point in the domain here, from x equals 0 up to x equals 9. Every point here is defined. But if I had an open circle, then that would mean that it was not defined at a certain value for x. Okay, so watch out for that in MathSpace. And you'll probably catch on pretty fast if you get it wrong when something's defined or not defined at a given point. You'll probably figure that out pretty quickly, okay, by getting it wrong and having MathSpace tell you, okay? But if it were an open circle, we would say it was not defined at that particular value of x. But since I have closed circles all over the place here, it is defined everywhere along these domains. All right, good luck with the MathSpace. That's it for notes.